Okay, so we ran out of time earlier. So this is the remaining workshop by video. So if you'd like to watch this alongside working through the booklet, if you're unsure of any bits, you can work through as you go. So if we have a look at question number 2 in the ratio and proportion, this is a word problem where you have lots of information, and again, you need to pull the information out and work it through. So Arish counts the money in his money box. He has saved 10p and 50p coins in a ratio of 7:3. There are 42 50p coins. How much money is in the box in pounds and pence? So we have our 10p and we have our 50p. We are told they're in a ratio of 7:3. And we know the 7 goes under the 10 and the 3 goes under the 50 because they're always given respectively. And there are 42 50p coins. So we can put 42 underneath here. Now to go from 3 to 42, if you can't do that mentally, put 42 into a bus stop, divide by 3. So 3 will go into 4 once, carry 1, and 3 goes into 12 4 times, so 14. So you're timesing by 14 on this side. So you then need to times by 14 on this side. And 7 times 14 would be 98. So you've got 98 10p coins. So that's the first stage completed. You now need to work out how much money is in the box. Well, you have 98 10p coins. So you would do 98 times 10 would give you 980 pence, which is £9.80. And then you have 42 50p coins. Well, there are 2 50p coins in a pound. So if you half 42, you would have £21. And you can add those two together, and that would give you a total of £30.80 in the money box there. Right, let's have a look at one more ratio question here. So this is very similar to the question in the 2020 paper, and quite similar to the one on with Elsie, Francesca and Gayati that we did in the lesson. So if we look here, we've got Paul, Stefan and Elliot raised 1,260 for a local charity. Stefan raises twice as much as Paul, and Elliot raises 3 times more than Stefan. So you need to put your column headings. So that would be S for Stefan, P for Paul, and E for Elliot. You then need to decide who raised the least amount of money. Well, Stefan raised twice as much as Paul, and Elliot raises 3 times more than Stefan. So that means that Paul raised the least. So we're going to give Paul a ratio of 1. Stefan raised twice as much as Paul. So Stefan would be 1 times 2, which is 2. And Elliot raises 3 times more than Stefan. So Elliot is 3 times 2, which would be 6. Okay, so we have the total amount they raised as well up here of 1,260. So we can put in another column for totals. We can total our shares. So we've got 2 plus 1 plus 6, which equals 9. And that needs to go into 1,260. And again, you can do your bus stop. You don't need to do this mentally unless you are able to, but it's always better to do your working out. 9 will not go into 1. 9 will go into 12 once, carry 3. And 9 goes into 36 4 times. And 9 goes into 0 0 times. So we are timesing by 140. So we can apply that to our ratios here. So that would make Stefan 280. Paul would be 1 times 140, which is 140. And Elliot is 6 times 140. So that would be 840. Okay, so you've got all 3 amounts now. Now you're in a position to answer the question quite easily. How much does Stefan raise? Well, Stefan raises £280. And part B is asking, how much more does Elliot raise than Paul? And Paul raises 140, Elliot raises 840. So you can subtract those from each other, and that will leave you with £700. Okay, so that is the best way of tackling those ratio questions there. So you now have quite a few ratio questions to work your way through. Oh, that's it on the ratio question. Sorry, I thought I'd put more in there than that, but no. Now, measures. If you don't know your measures, learn them, please. It's going to make your life so much easier. your equivalents. And if you're not sure of which way to go, whether you're adding or dividing, if you follow what I'm doing here, you will be able to hopefully sort that out in your own head as well. Now, a bottle contains 0.35 litres. How many millilitres is this? Now, milli stands for 1,000. So millilitres, there are 1,000 in a litre. Centi stands for 100. So in centimetres, there are 1,000 in a centimetres. 100, sorry. Centi stands for 100. So 100 in a centimetres in a metre. Dec, if you have anything with dec, that stands for 10. Now, kilo also stands for 1,000. It's 1,000 of. So kilograms would be 1,000 of grams. Okay, so that's how that one works there. Now, if we have a look here, we've got a bottle contains 0.35 litres. How many millilitres is this? We are going 1 litre equals 1,000 millilitres. So to go from 1 to 1,000, you are timesing by 1,000. So you would take your 0.35 and multiply by 1,000. So you're going to move that decimal point 1, 2, 3 spaces. Your decimal point would land there, and you need your placeholder there. So your answer would be 350 millilitres. Now, a picture is 540 millimetres tall. What is this measurement in centimetres? Now, there are 10 millimetres. 1 centimetre equals 10 millimetres. So we've got 540 millimetres. So to go from 10 to 540, we are timesing by 54. So 1 times 54 will give you 54 centimetres. And that would be your answer there. So again, you can use your ratio methods if you wanted to for measure as well. Or you could say, well, to go from 10 to 1, I would have divided by 10. So you can divide your 540 by 10 and go there. Now, a bag of flour contains 1,029 grams. Rewrite this quantity in kilograms. So 1 kilogram equals 1,000 grams. We've got 1,029 grams. Now, to go from 1,000 to 1, we would divide by 1,000. So you would take your 1,029. Now, when dividing, remember that the decimal point is always sitting here after the ones number, even if you can't see it. So if there's no decimal point in your number, you can put it after the ones number. If you're dividing by 1,000, there are 3 zeros in 1,000, so you move it back 1, 2, 3, and it would land there to give you 1.029 kilograms. Now, this question down here, you're adding together different measurements in different units. So we have 1 millimetre, 0.1 centimetres, 0.1 metres, and they want you to give your answer in centimetres. So before you begin, convert them all into centimetres. So 1 millimetre, remember there are 10 millimetres in a centimetre. So 1 millimetre would be 0.1 centimetres. You have 0.1 centimetres here already. And then you have 0.1 meters. Now there are 100 centimeters in a meter. So 0.1, to convert it into centimeters, you would times by 100. So you go forward 1, 2 spaces, and that would disappear, and you would have 10 centimeters. So altogether, you can add these ones together. You've got 0.1, 0.1, and 0, 10.0, and that would give you 10.2 centimeters. Now, part E is, again, this is about area. The area of a postage stamp is calculated as 2 centimeters by 2.5 centimeters, which equals 5 centimeters squared. What is the area of the stamp in millimeters squared? Now, they're looking for you to just go, oh, well, there's 10 millimeters in a centimeter, so we're just times by 10. Play it safe. In an exam, the adrenaline is pumping and you can you can miss the point sometimes. So always be methodical and kind of work your way through. The area of a postage stamp is calculated as 2 centimeters times 2.5 centimeters. Change that into millimeters. So we've got 20 millimeters times 25 millimeters. So now you're going to do 20 times 25. So I would split the 20 into 2 and 10. I would times 25 by 10. to give myself 250, and then I would times that by 2 to give myself 500. So your area is 500 millimeters squared. That would be your area there. Okay, so there's your measure conversions. They are coming up a lot at the moment, and they tend to come up in this format here, which has you multiplying and dividing effectively by 1 million. But again, do it step by step. You're told 1,000 milligrams equals 1 gram and 1,000 grams equals 1 kilogram. You want to convert kilograms into milligrams. So take your kilograms, convert them into grams first of all, and then convert them into milligrams. Okay, so you would take your kilograms, to go from kilograms to grams, you would times by 1,000. And to go from grams to milligrams, you would times by 1,000. Now, I'm not going to tell you the answer to this. The answer will be in the answer booklet, but you can have a go at that there. And the same, this time you're moving from milligrams to kilograms. And I would advise going via grams. So to go from milligrams to grams, there are 1,000 milligrams in a gram. So you're going from 1,000 down to 1. So you would divide by 1,000. And to go from grams to kilograms, there are 1,000 grams in 1 kilogram. So you're going from 1,000 down to 1 again. So you are dividing by 1,000. And again, you can check your answer booklet to see if you've got the right answer there. Now, let's have a quick look at probability. Probability isn't really in the Key Stage 2 curriculum anymore. However, it can appear in the 11 plus because it is testing your ability to apply logic, if you like. So here we have Louis selects a ball with a letter from the bag below. What is the probability that the ball he has chosen has a B on it? Give your answer as a fraction in its lowest term. So first of all, you need to count how many balls there are in the bag altogether, and the answer is 9. So that will be the denominator of your fraction. And then B's, you've got 1 here, 1 here, and 1 here. So you have 3 chances out of 9 of finding a B. And if you simplify that down, that would become 1/3. Now, a letter is chosen at random from the word below. The word is 17. What is the probability that the letter chosen is an E? Give your answer as a fraction in its simplest form. So first of all, count how many letters there are in the word 17, and that will be your denominator. And then count how many E's there are in the word 17, and that will give you the probability of you choosing an E. And then simplify as required. Okay, so simplify as required. Then we're going to come down, we're going to have a look. Another way that probability can come at you is in the form of dice questions. And we are going to look at consecutive probability here as well. So what is the probability of rolling a prime number? Give your answer as a decimal. So this is testing your decimal conversion, your fraction decimal conversion. This is testing your knowledge of prime numbers. They're testing lots of things in this one question. So think about which of the numbers between 1 and 6 are prime and how many of them there are. So the number of prime numbers will be your numerator at the top. And how many, on a 6-sided dice, you have 6 possible outcomes. Okay, so 1, 2, 3, 4, 5, or 6 are your possible outcomes. So how many prime numbers are there? And that will help you form your fraction there. Again, I'm not telling you the answer. You can go and have a look in your answer booklet. Now, the second question is very, very similar. We're going to have a look at C, though, together, and I will work through this one. What is the probability of rolling a double 3 with 2 6-sided fair dice? Now, when they say fair dice, they're just saying that there is an equal chance of any of the 6 numbers coming up. Okay, so that's all they mean by that there. Now, double 3. So on the first dice, we have a 1 in 6 chance of throwing a 3. And on the second dice, we also have a 1 in 6 chance of throwing a 3. Now, to work out the likelihood of both of those events happening, you find the probability of each event and then you multiply them together. So this tests your multiplication of fractions. So it would be 1 times 1 is 1, and 6 times 6 is 36. So your answer would be 1/36. Okay, and that's how that goes there. Now, let's go down, have a look at symmetry. So let's come down here, symmetry and coordinates now. So you may be asked to do reflective and line symmetry. You may be asked to do rotational symmetry, and we'll look at that later on as well in the video. Now, if you have to do reflective symmetry, you want the shape to match the shape on this side. And if we're reflecting over this line here, our reflection is going to come up here. And if it helps you, it depends. Some people are really good at these and some people find them tricky. Dot each corner. Okay, so if you dot each corner, each dot would have to be reflected on the line. So this dot is on the line, so it would stay on the line. This one is 2 away from the line, so it's going to be 2 away from the line up here. And this one is 2 away from the line here, so it's going to be here. And then you can effectively draw your lines and go from here. Reflecting over a horizontal or a vertical line is quite straightforward. When you do so, try and be as neat as possible. Use a ruler, shade in. Sorry, that's my dog. I think he's quietened down. And then we are going to now look at what you do over reflecting over a diagonal line. Now, again, if you're visual and you find this thing really easy, it won't cause you any problems. If you, like me, find visual things quite tricky, again, dot your corners if it makes it easier. Okay, so we'll deal with these ones first of all. And always think of it in terms of coming to the line in a straight line. So here, we would go diagonally across one square. So that dot is going to transport itself over here. Now for this one, we are going to go diagonally across 2 squares to the reflecting line. So we need to diagonally go across down here. So that's where that dot would go. So we've got another dot here. Now this one up here, let's have a look. And again, this is 2 going diagonally across 2 lines. So it's going to go diagonally across 2 lines here. And you now have your dots. Okay, so this dot here has been reflected here. This dot has been reflected here. And those 2 dots can be joined together with a line like this. This one has been reflected here, and this one has been reflected here, and they're joined together. And from there, you can recreate your shape quite effectively. And if we go across 1, down 1, and there you go. And you have reflected there. If you have used guidelines, just rub them out at the end, just so that they're not on the drawing, and you can make it nice and clear there. Okay, so that's reflecting across, that's a strategy for reflecting across a diagonal line. Now, rotational symmetry, about the center of order 2. So we want to create a shape that will land on itself 2 times as it goes round. So if you can imagine sticking a pin in here and then rotating this so that it lands on itself twice. So basically it would need to have its reflection at 180 degrees. So we're going to be shading up here. We can leave this L shape here blank. So this bit here stays blank. And you would shade in here. This one here is basically this one here. Okay. This one here will be, not there, sorry. This one here will end up over here. Okay. And then your three squares will come down here and be in this bit here. Okay, and if it helps you, you could get some tracing paper or some very thin paper that you can see through, and you can trace the shape and stick a pin in the center of that circle and swivel it round, and you'll see that how this will land on here, this will land on here, and this will land over here. Okay, let's come down and have a look at a couple of CSSE style questions with regard to rotation. So again, you can be tested on coordinates and rotation and reflection on the grids as well. So if we look here, we've got the coordinates of the point on arrow A are -2, 2. So they're talking about this point here. Okay, so the coordinates of that point there are -2, 2. If arrow A is reflected in the y-axis, now remember the x-axis goes across. Okay, so it goes, an x is across, an x goes across, and the y-axis is your vertical axis. And I always think it's X goes across and Y to the sky. Okay, so Y goes up and down. Now this coordinates grid here, it has been split into 4 quadrants. You have your positive Y here, you have your origin or 0 here, and then you have your negative Y coordinates here. Positive X coordinates go along here, negative your X coordinates go here. Now remember, with your coordinates, you always go along the corridor before you go up the stairs. So the X coordinate always comes first and the Y coordinate comes second. If it helps you to remember, X comes before Y in the alphabet as well. So you always do the X first. Now question A is saying if arrow A is reflected in the Y axis, so it's going to be reflected over this line here, okay? What will be the coordinates of the point on arrow A? So when it's a reflection, it's an equal distance from the line on both sides. So this is 2 squares away here. So it's going to be 2 squares away here. So the point on the arrow in the reflection would be here, and that would be 2, 2. Now, if we look at question B, if arrow A is rotated 90 degrees anti-clockwise about the origin, what will be the coordinates of the point on arrow A? Now, again, this depends very much on how visual you are. Some people are wonderfully visual and they can see it. Other people find it tricky. So I want you to imagine that point A, like a balloon, is tied onto the x-axis here. Okay, so that is tied there. It cannot move. Now, I find it easier to think of the x-axis itself rotating, not the shape. Okay, so the x-axis rotates, but point A will stay tied onto the axis at the same point. So we're going 90 degrees anti-clockwise. So that means we're going to rotate the x-axis round to here. Okay, so that is your 90-degree rotation. Point A is still tied on at the second point on this axis. So point A is still going to be tied on here. And if we were to come out, that's 2 squares off the axis to here, we would then have our new coordinate for point A. Now, I'm going to try and draw this freehand. It's not going to be brilliant, but I'll draw the shape so you can kind of see roughly how it goes. So if we come across here, the shape is now facing this direction. This is not the easiest shape to draw. Let's just come down to here. So this is now the orientation of that shape. Okay, you don't need to draw the shape, you can just focus on the coordinate. So the coordinate point now for our shape here for point A would be -2, -2. Okay, so it's -2 along the x-axis, -2 on the y. If the shape above is translated 5 squares to the right and 6 squares down, what will be the new coordinates of the point of arrow A? So you need to move 5 squares to the right. So if you come here, so if we go here, oh, this is a bad question I've written. Shape above is translated to the 5 squares to the right and 6 squares down. I think we have to talk about it being the original shape because we haven't been told it's the reflection. So if we take this shape and we go 5 squares to the right, so count 1, 2, 3, 4, 5, 5 squares to the right, 6 squares down, 1, 2, 3, 4, 5, 6. This will be where point A would land there. So the point on arrow A would land here, and the new coordinates for point A would be 3 on the x-axis and -4 on the y. Now, in the CSSE, this will be much clearer as to which shape you are translating. But if it doesn't tell you, it's always the original shape, okay? Unless it's asked you to draw the shape in. You didn't need to draw a new shape in here, so it will always be the original shape that you're working with. Okay, so you have some more of these to practice with. So remember with your rotations, always think about the axes moving and the points being tied on at set points on those axes. And you can have a go at question 2, and you can have a go at question 4. So again, it's about reflections and rotations. Okay, and now let's go and have a look at our final topics, Angles and triangles. Now you will be expected to be able to recognize the different types of triangle. So there's equilateral triangles where all 3 side lengths and all 3 angles are equal. Isosceles triangles where you have 2 equal side lengths and 2 equal angles. Scalene triangles where all sides and all angles are different. You will be expected to know that there are 180 degrees on a straight line. You will also be expected to know that there are 180 degrees in a triangle and 360 degrees in a quadrilateral. You will be expected to recognize a right angle. There are lots of different ways they can test your angle knowledge. Okay, so let's have a look at this first one here. So these 2 lines here tell us that these 2 sides are equal. Therefore, this is an isosceles triangle. Okay, so these are the kind of things you need to be thinking through in your head. So it's an isosceles triangle, 2 equal sides, it will have 2 equal angles. The 2 equal angles are always at the bottom of the equal sides. So this angle here will also be A. You've been given the top angle or the single angle at the top. There are 180 degrees in a triangle. So you would subtract the 20 degree angle that you know, which would leave you with 160 degrees. And because these 2 angles are equal, you would divide that by 2 and angle A's value would be 80 degrees. Now again, you have another isosceles triangle here. This time you've been told the solitary angle is 62. Therefore, you would then have this and this angle here would be equal. Okay, so this angle and this angle are equal because this is an isosceles triangle. You can use this information to work out these 2 angles. Then this angle here is sitting on a straight line with angle K, and there are 180 degrees on a straight line, and you should be able to work it from there. Okay, so I'm not going to tell you the answer to that one. You can check that on your answer book. Now, same with question C. This is all happening on a straight line. You will be expected to know how many degrees there are on a straight line. And then we have 3m, a right angle, and m. These 3 amounts together will give you 180 degrees. So if you want to look at it, you can make this into an algebraic equation. You have 4 m's. A right angle is 90 degrees. So 4 m's plus 90 will equal 180 degrees. And you can use that information to work out the value of m. Okay, so you can use algebra to work out the value of m there. Let's come down and have a look at part D. So part D, we have, again, you've got 3 dashes here, which tell you that all of these sides are equal. So this tells you that this triangle up here is an equilateral triangle. Okay, so it's an equilateral triangle where all sides and all angles are equal. And this is a 4-sided quadrilateral. Well, this is a quadrilateral with 4 equal sides. So therefore, this must be a square. Okay, so they now expect you to use your knowledge of equilateral triangles and squares and their angle sizes to answer the questions here. So D, what is the size of each angle in an equilateral triangle? Now, you know there are 180 degrees in a triangle, and an equilateral triangle has 3 equal angles. So that will enable you to calculate that there and put that in. I'm not going to tell you again. I want you to think about it. Whatever this angle is, this bit here will be the same. Okay, so this is the same as D. And E is one of your angles from your square. And angle E is the sum of this angle here and this angle here. So you should be able to work out where the E is the angle for the square, but the E actually refers to this whole angle here. The sum of this angle here and the sum of this angle here will give you your value for E. Now, let's quickly, finally, have a look at circles. Circles come up very, very rarely. However, if they do come up, your requirement to know about, or what you're required to know about circles is actually quite narrow. Let's just talk, forget the question for a minute, let's just talk about circles. Circles, you would need to know that the outside edge of a circle is called the circumference. You would have to know that the diameter is the distance through the midpoint of a circle from one side of the circle to the other. You would then be expected to also know that the radius is the distance from the middle of the circle to the outside edge. The radius is always half of the diameter, so therefore the diameter is always double the radius. Okay, so if you know one, you can work out the other quite simply. If they were to ask you to calculate area and circumference of a circle, I would expect them to give you your formula, the formulas you would need to do that. Again, I can't recall it ever on a CSSE 11 plus paper. It has appeared on other 11 plus papers. Now, in order to calculate the area of a circle, I'll give you the formula now. So the area of a circle, you would use the formula pi r squared. Okay, and pi, I would expect them to give you the value for pi of 3 or 3.14. Okay, you wouldn't be expected to know that. So to calculate the area of a circle, you would multiply the radius, well, you would square the radius and then multiply it by 3.14. To find the circumference of a circle, let me just write this up here. And again, if they ask you to do this, I would expect them to give you the values, because this is not something you would do, I don't think, in most schools until later on in year 6. So to find the circumference of a circle, you would use this formula, which is pi d. Okay, so it's pi times the diameter. All right, so that's what you would do there. Now, this question here is basically looking for you to recognize what you would know about the diameter and radius of a circle. So you've been told the area of the rectangle below is 96 centimeters squared, and y equals 2 centimeters. Inside the rectangle are 2 identical circles. What is the radius of one of the circles? Now, you know that your width of your rectangle is 6. You know that the area is 96. Now, area equals length times width. So, and here we have length times 6 equals 96. So to find the length, you would do 96 divided by 6, which would equal 16. So you now know the length of your rectangle is 16. Each of the y's is 2. So this is 2, this is 2, and this is 2. So 2, 4, 6. So the diameter of each of the 2 circles must total 10. So this diameter here, diameter equals 5, and the diameter here equals 5. Now, what is the radius of one of the circles? Well, we know that the radius is always half of the diameter. So the radius of one of the circles would be half of 5, which is 2.5. What is the distance between the center of the 2 circles? Now, the center of the 2 circles, so we've got the center here and a center here. We would have a radius here and a radius here and y here. So the distance between the center of the 2 circles would be the radius plus y plus another radius. And I'll leave you to work that one out. So apologies we didn't get all of this covered in the session, but hopefully this video will help. The mark schemes have been sent to you or are on their way to you, and you can hopefully work your way through some of these and find it useful. I wish you all the best of luck in your exam, and it was lovely seeing you today. Thank you.